Hello, this is Mr. Franklin's Math 1. We're working on Unit 2, Statistics, Lesson 2, Measures of Center. This is the homework problem on page 131, problem number 5. To see that problem here, we've got problem number 5 on 131. The table below gives the price and size of 20 different boxed assortments of chocolate as reported in Consumer Reports. I'm pretty sure that that number 20 right there, that there are 20 different boxed chocolates, is going to come in handy. Scrolling down, I can see part A says that the cost per ounce is missing for Godiva and for C's. Let's look at that. Godiva, yep, the price per ounce is missing. And for C's, famous old-time assorted, the price per ounce is missing, so we'll have to calculate those. And we can also calculate the price of a whole box of Leonidas Pralines General Assortment 28. Wasn't Leonidas the guy from 300? Anyway, I'm going to bring up the calculator. It works just like your own calculator. Let's take a look at Godiva first. If a box of Godiva is $35, then I multiply that by, I divide that, where's divide? Right there. I divide by the number of ounces to get the price per ounce. And this tells me that 1 ounce of Godiva's gold Ball-O tin is going to cost me $2.19 when I round off. Clearing that, I'm going to look at C's famous old-time assorted. Same process, $13 for the whole box, divided by the number of ounces in a box, 16. That gives me, it's 81 cents per ounce when I round off. Then looking at Leonidas Praline General Assortment, going backwards, if 1 ounce is $1.75, and there's 16 ounces to the box, we're just reversing the last calculation that we did, then a whole box of Leonidas is going to cost $28, which seems a little high for a box of chocolates to me, but we're going to now move on and close my calculator here and move down to examining the histogram. We're now looking at this histogram over here. Let me zoom in on that just a little bit. There we go. The histogram to the right shows cost per ounce data. Examine the histogram and make a sketch of what you think the box plot of the same data will look like. Then make the box plot and check the accuracy of your sketch. Well, I need to examine this for a second here. I know that there are a total of 20 data points here, and we're dealing with cost per ounce. The frequency of each tower is the same as the height of the tower. So if there are 20 items here, the first thing I need to find in the 5-number summary, which I'm going to use to make my box plot, is the median. And I need to find whatever is halfway in between the 10th and 11th value for the median, because there's 20. Split 20 in half, you get 10. So there's 3 items in this first tower, plus 2 in the second tower makes 5, 2 in this next tower after the gap makes 7, and then plus 1 is 8, plus 1 is 9, and then the 10th one and the 11th one live here in this tower, which starts at 2 and goes between 2 and $2.25. So I am going to estimate the median just right here at $2. Next, I need to find the first quartile. I find that by looking at, well, I know that there's 20 total items, so the first half contains 10, so I need to find what's halfway in between the 5th and 6th values. Looking back here, I've got 3 plus 2 in the first 2 towers, that's 5, and then the 6th value is over here. So we've got to go halfway in between $1.75 and, sorry, that's not $1.75. That is 75 cents and $1.25. Looking at that, halfway in between 75 and 125, I'm going to estimate that to be about 1. So quartile 1 is 1. Go over here and perform the same operation on the upper half, starting from the top. There's 1, 2, 3, 4, 5 from the top. That's where quartile 3 is going to be. Because if quartile 1 is right after 5 from the bottom, quartile 3 is going to be right before 5 from the top. So 1, 2, 3, 4, 5, and I'm going to estimate the quartile 3 to be $3.50, because that's what's right here in this bar. The minimum, of course, I can see from here is going to be about 50 cents, and the maximum, of course, is going to be about $4.50. So I'm going to write down all those numbers and get right back to you. So here are the numbers that we've been working with. The prices for Godiva chocolate and See's chocolate per ounce, and then the box price for Leonidas, and then I estimated the 5-number summary, and the numbers that I just read off of a median of 2, quartile 1 is 1, quartile 3 is $3.50, minimum is 50 cents, and the maximum is $4.50. And our job is to make a box plot from these estimates. So I'm going to move this off to the side, and you can see where I've been making a number line. It's the same number line as the one in the book on the problem, and I'm just going to put in the numbers that I got from the 5-number summary, which go like this. The median is 2, so I'll put a vertical line there. Quartile 1 is 1, put a vertical line there. Quartile 3 is $3.50. The maximum is $4.50, and the minimum is 50 cents. And when I connect here and here, I've got the center of the box, and then you can see the whiskers. So the next part is to compare this to the actual, using the actual numbers. I'm going to switch and use my calculator for that. Because I don't currently have a good way to film my calculator without it being overly blurry and you can't see it, I've chosen to use CPMV Tools, which you all have available on your computer, which you can download if you don't have it already. And I chose, under the Statistics tab, I chose Data Analysis, which brings up a nice little spreadsheet, and to save time, I've entered in the data, including the 2 values that we calculated in Part A, $2.19 per ounce and 81 cents per ounce, and I named this column after cost per ounce, and I'm just going to look at a box plot. I'm going to choose a box plot for this. You should know how to do this on your calculator as well, but there are some neat things that you can do with the CPMV Tools. You can't use it on a test, can't use it on the SATs like you can with your calculator, but there's some neat, fast, good data analysis stuff that you can use here. For example, the number line down here matches what I did on the piece of paper when I was estimating things, and the box plot looks about the same. I can go up to Tools for this menu for basic statistics. This is the same as the 1-var stats that we see on the calculator, and you can see that all of the stuff that we need is here. For example, for the 5-number summary, we've got the minimum is 0.5, same as we had in our estimate. Quartile 1 is a little bit off, but notice that it's within 25 cents. I estimated $1, and inside that same column on the histogram would have also been $1.14. Similarly, the median is $2.16. Quartile 3 is $3.54, and the maximum is $4.62, whereas I estimated $4.50 before. And you can see those values here on the box plot. The minimum here, the blue box in the middle, is the interquartile range, which goes from $1.16 up to $3.54. And then the maximum, of course, is $4.62. So we've now compared our estimates to the computerized version of this, which is the same values that you would get on your calculator. You should check that. And The box plot here and the 5-number summary are approximately the same. Each value is within 25 cents of our estimate, which for this context is good enough. For the last part of this that I'm going to go over today, we're looking at part C, which talks about identifying any outliers in the cost per ounce data. This whisker right here doesn't look like it's long enough for there to be any outliers, nor does this whisker right here, but I've got to run through the process anyway. So C is all about identifying outliers. And for upper outliers, we're going to use Tukey's rule, which says quartile 3 plus 1.5 times the IQR. And once I calculate that number, anything bigger than that is going to be a outlier. I'm using my calculator off to the side, which I know you can't see, but quartile 3 is right here. It's $3.54. And I'm going to add to that 1.5 times. Now, I need to know what the IQR is. The IQR is quartile 3, which is $3.54, minus quartile 1, which we've got $1.14. So the IQR is $2.40. Multiplying that by 1.5 gives me $3.60. So any number bigger than 3.54, which is quartile 3, plus $3.60, which is 1.5 times the IQR. Add those numbers together to get $10.74. And obviously, since the highest number in our data set, the prices, is $4.62, that's not higher than $10.74. So there are no upper outliers. Got to do the same to check the lower outliers, even though it seems obvious that there are no lower outliers. We need to check anyway. This one's a little bit different because I need to take Q1 and subtract 1.5 times the IQR. So if this is quartile 1, anything $3.60 lower than that gives me the boundary for where anything beyond that is going to be a outlier. And clearly there are not any, but here's the math anyway. Quartile 1 is $1.14 minus 360. Do that on my calculator, and I get negative $2.46. So there are no prices lower than negative $2.46. A word of caution here: if you subtract the wrong one first, like if you do $3.60 minus quartile 1, you'll get a positive $2.46, which on the graph is right about here. And of course, there are lots of numbers lower than that, so that can cause some confusion. Make sure that you are following the formula correctly, and you're doing quartile 1 minus 1.5 times the IQR, not the reverse of that. And that's everything that there is about outliers in this situation. In other words, there are none. To sum up, that was page 131, problem number 5. And if you have any further questions, just ask or rewind this video and rewatch the relevant parts again until you can figure it out on your own. Thank you very much.